Hello friends, in the previous lecture we have got to know that is what is octet rule, and because of which we have got to know that is various of the chemical bond formation is the one which follows the octet rule, and that is how the bond takes place and between all during sharing of electrons, or we could say during the transfer of electrons. But there are certain limitations of the octet rule. So what are the limitations? Let us talk about it. So basically the limitation of the octet rule, or basically we could call it as inadequacies of the octet rule. There are certain molecules which are not following the octet rule but still are found to be more stable in nature during the bond formation. So in this case basically we are going to talk about basically the three things, that is the one which has incomplete octet but still they are forming the bond, and as well as they are forming a stable compound, and talking about the one which are having more than 8 electrons in its outermost shell or in its valence shell, still they are called to be, that is a stable compounds forming the bond. And talking about, there are also certain molecules which have odd number of electrons, and so this is the thing that we are going to talk about it. So let us understand with the first one, that is so let us understand the certain molecules that we are going to give an example of, that the one which are not following octet rule but still are basically stable in their nature. So talking about the first kind of that is limitation, or first kind of inadequacies of the octet rule, and that is incomplete octet. There are certain compounds which form bond but they don't have the complete octet, and for complete octet we need 80 electrons in its valence shell, but they have incomplete octet. That means we could say that they have less than 80 electrons in its valence shell during the bond formation. So that is what I am going to try to explain about the incomplete octet. And while taking an example, that is I could take an example of, that is BeCl2. So this is basically a stable compound, and basically it is ionic in nature. But still, suppose how the bond takes place in this case. Talking about the beryllium, so beryllium is the one which has an atomic number of, that is 4. So I could write it as the electronic configuration, that is 1s2, 2s2. So in this case, we could see that the outermost that is orbit of the beryllium, it consists of 2 electrons over here. So and it has to form bond with 2 chlorine atoms. So let us understand that how we can represent the bond formation of between beryllium and chlorine. But before understanding that, we should also know that what is the electronic configuration of chlorine. So let us understand it. That is, the chlorine can be written as the atomic number of chlorine is 17. So I could write it as, that is 1s2, 2s2, 2p6, 3s2, and 3p5. So third orbit is the outermost orbit of the chlorine atom, and we could say that there are basically 7 electrons in its outermost shell. So that's the reason that chlorine needs only 1 electron for it from beryllium, so as to convert into its complete octet, or we could say like it will behave like a noble gas in terms of electronic configuration. But is it possible for the beryllium to show complete octet? Let us talk about it. So talking about the beryllium atomic number, or talking about the, that is valency or valence electron of beryllium. So beryllium is the one that could be written as in this form, which consists of basically 2 electrons, and those 2 electrons are basically, I would represent it over here. While that of the chlorine atom, and chlorine atom consists of basically 7 electrons in its outermost shell, and that's the reason that we could represent it in this way. 3, 4, 5, 6, and the 7th electron, that is what it will form a bond with. So suppose it is this one. So that's make the chlorine to be basically forming a bond between beryllium and chlorine atom. So that will be a bond formation of one bond formation. But talking about the another chlorine, even the chlorine, another chlorine will form a bond with that of the beryllium, and even that will have a structure, or we could write it in a basically Lewis dot structure in this way. But I am representing it with a cross, just to differentiating between that this electron is of beryllium, while cross is the one that represents the electron of the chlorine, and that is what I am representing over here, suppose. So in this case, we could see that this is what it forms. So talking about the chlorine, chlorine is satisfying the octet rule, and that's the reason that its outermost shell, or outermost that is orbit, consists of total 8 electrons with 1 electron of the beryllium, and making this to be basically behaving like that is a noble gas electronic configuration. While talking about the beryllium, beryllium is the one which has an outermost shell which is now been accompanied by basically 4 electrons. But it should have at least, suppose if it has to be behave like helium, then it should have basically 2 electrons in its outermost shell. But meanwhile, only the helium is the one which has 2 electrons in its outermost shell, and that is the first shell, and that makes it to be a noble gases. While talking about beryllium, beryllium also, being though it has 2 electrons in its outermost shell, it doesn't behave like helium. But still, by acquiring the 2 electrons from each from the chlorine atom, as we could see, so it has an outermost electron that are being left in beryllium's valence shell is basically 4. So it is not 8, so therefore it is less than 8, and that's the reason that it is the one which is behaving, or which has basically incomplete octet, but still the compound is very stable, and that is how we could see that the beryllium forms 2 bonds, one bond with chlorine and another bond with another chlorine. So this is the thing that has been formed. We're talking about the beryllium. So beryllium is the one which is basically belonging to, that is so here we could see that the beryllium is the one which is forming the 2 bonds, and it is stable. So therefore it is being giving an incomplete octet, and still it is a molecule that has been formed. So let me take another example, so that I'll make you assure that there are still certain compounds which are basically stable in nature. In fact, not being following the octet rule. So the other one that I'm going to talk about, that is BF3. So basically this is boron trifluoride, and that is what I want to talk about. And talking about the boron, so boron has an atomic number of, that is 5. So I could write it, the electronic configuration, this way, that is 1s2, 2s2, that is 2p1. So this is what I could write, or I could mention about it. And talking about the fluorine, fluorine's atomic number is basically 9, so I could write it as 1s2, 2s2, 2p5. So talking about the boron, boron has an outermost that is shell which is accompanied by 2s and 2p, and the total number of electrons that are present in the outermost shell are basically 3 electrons. So that's the reason that we could draw the structure of it, or the Lewis structure of the boron very easily. While talking about the fluorine, fluorine has an outermost shell of which consists of basically total amount of 7 electrons in its outermost shell, just like that of the chlorine. And let us see that how the bond forms between these two. So talking about boron, so boron is the one, suppose it consists of its 3 electrons, and that electrons are being represented in this way, that is 1, 2 and 3. So these are the 3 electrons that are being represented as the valence electron of the boron, and boron is the one that can form bond with fluorine. And talking about the fluorine, fluorine is the one which has basically 7 electrons in its outermost shell. So that's the reason this is the fluorine, which has basically 7 electrons in its outermost shell. But not all the 7 electrons will be forming bond with other compounds. Only 1 electron will be able to form a bond, and that's the reason that I am representing it over here in this way. So this is the fluorine electron that is forming a bond between the boron and fluorine over here. So this is it. So now if you observe fluorine, fluorine is the one that is following octet rule. That is, it has 7 electrons in its outermost shell, but while sharing the electron, or while taking the electron from one boron, so now it has complete octet, and that fluorine will behave like a noble gas in terms of electronic configuration. But this is the one that has been forming because of the sharing of electrons, because obviously we could see that the boron and fluorine, they form a bond between them, and that's the reason that obviously there will be sharing of electrons. Even boron needs electrons so as to form complete octet. But is it that it will form a complete octet? Let us talk about the another fluorine atoms that are going to form a bond between the fluorine. So this is 1, 2, 3, 4, 5, 6, and this is the 7th electron of fluorine. And now here also we could see that there would be a formation of a complete octet for fluorine, but not for boron. So now let us consider the another that is atom that is going to form a bond with fluorine, and that consists of 7 electrons in its outermost shell, and this is the 7th electron. And here also we could see Then the fluorine is the one that has formed a complete octet and that is now stable. We're talking about boron. So boron ultimately has basically 6 electrons in its valence shell. So therefore this is 1, 2, 3, 4, 5, 6. 6 electrons in its outermost shell. But still, is it the one that is showing a stable structure? Yes. And it is not following octet rule, because in octet rule we need basically 8 electrons in its valence shell, and that's the reason that boron is the one that is not following the octet rule, but still it is forming a stable structure, and that is how we could see the structure of BF3 as this one. So here the octet rule has failed to explain the inadequacy, or we could say the limitation of, these are the limitation of the octet rule, and this is what I have explained about the incomplete octet. So these were the two compounds, a common two compounds that I wanted to explain, but there are also certain things that I wanted to explain. So this was basically the incomplete octet rule. So these are the examples that were following the limitation of the octet rule, and that was basically incomplete octet. And now let us understand that we are going to describe about the stability of those compounds whose central atom is the one which is having more than 8 electrons, and that are basically known as expanded octet. So what are expanded octet? Let us talk about that. So the expanded octet can be given with the help of an example. So let me explain you this with an example like PCl5. So PCl5 is the one, is an example which is basically stable in nature compared to that of the one which is not following the octet rule, because there are also certain kind of the compounds that are not following octet rule, and that's the reason they are unstable. But these are the kind of stable compounds that are, although not following the octet rule, but still are found to be more stable. So talking about this one, that is talking about phosphorus. Phosphorus is the one which is now the central atom of this whole molecule, and that is the reason that it has for which we could see that the atomic number of phosphorus is found to be 15. So we could write the electronic configuration like 1s2, 2s2, 2p6, 3s2, 3p3, making this to have basically 5 electrons in its outermost shell, and the outermost shell is the third shell. And talking about the chlorine, again we are talking about chlorine. So chlorine is the one which will have an electronic configuration of, that is 1s2, 2s2, 2p6, 3s2, and 3p5. So now basically one phosphorus will be in the middle, while the rest of the chlorine atom that would be that would surround the phosphorus atom, and or we could say that the central phosphorus atom. And let us see that how the bond formation takes place, and whether the phosphorus is the one which is following octet rule or not. That is what we are going to talk about, and how it follows, that is expanded octet. So let us talk about it. So talking about the phosphorus, phosphorus is the one which will be in the middle of that is the molecule, and it has basically, as we could see, that it has basically 5 electrons in its outermost shell, as you could see over here, 5 electrons in its outermost shell, and that's the reason that the bond that could be formed by the phosphorus to form PCl5 is basically 5 bonds. So that is what I am going to represent it with the help of dot. Suppose this is the structure that I want to explain about. So these are the valence electrons of the phosphorus that I am explaining over here. And talking about the next thing, that is there are basically, we know that it's 5 chlorine atoms that will be surrounding the phosphorus atom. So let me explain this with I write it over here. Again, it consists of 7 electrons. So 1, 2, 3, 4, 5, 6, 7. So there are 7 electrons in its outermost shell of the chlorine. But talking about the chlorine has a tendency to accept electron at anyhow, because it has to give the stable electronic configuration just like that of the noble gas. So obviously it will have the capacity of taking an electron, so it will take then acquire an electron of that of phosphorus. So only this part is the one which has been acquiring by the chlorine, and it is acquired by the chlorine to get an electron from phosphorus. But meanwhile, phosphorus is also the one that forms that needs electrons so as to get stable electronic configuration. So obviously, so now we could say that these 2 electrons, they will be shared by these 2 atoms like phosphorus and chlorine. So similarly, in this case, every chlorine that is been attached to that of phosphorus will have a kind of, we could say that they will share their electrons. So this thing will happen, and that's the reason that chlorine will be an atom that will acquire stable electronic configuration. But what about phosphorus? So if you are talking about phosphorus, then let me explain you in this way. That is, phosphorus consists of basically 5 electron units outermost shell when it comes to an atom. But while forming a bond, we could see that there are basically 10 electrons in its valence shell. How? This phi of chlorine that I have represented by green dot, while this red cross, that is the electron that I have represented in form of electron of chlorine. So therefore, obviously there will be a bond formation over here, and that's the reason that 10 electrons are in the outermost or the valence shell of the phosphorus, but it should be 8, and that is what octet rule says about. But still, it is not following the octet rule, and still it has more electrons than that of an octet, and octet means 8 electrons, and that is the reason that it has 10 electrons, which is more than that of octet, and that's the reason this kind of structure that are obeying basically expanded octet, and that's the reason they are also being stable in nature. And that is what the octet rule fails over here, and this is an example where it consists of more than 8 electrons in its valence shell, and this is what I want to talk about. So this was one of the example of the expanded octet, and let me explain about the another one, that is SF6. Even SF6 is a very stable compound, and but let us see that whether it has been following the octet rule or not. Talking about the sulfur, sulfur is the one which consists of basically we could say like 16 electrons in its or 16 electrons, or we could say that is the atomic number of that. So I could write it over here as 1s2, 2s2, 2p6, 3s2, 3p4. So this is the electronic configuration of sulfur. While talking about the fluorine, fluorine is the one which has an atomic number of 9. That is what we have got to know already. That is 1s2, 2s2, and this is 2p5. While forming the bond between the sulfur and fluorine, and what kind of the sharing of electron takes place, or what kind of electrons or how many electrons that are present in the outermost shell or the valence shell of the sulfur, whether it is following the octet rule or not, let us talk about this one. I hope you have got to know, you are getting it, that how the bond forms over here. So sulfur is the one that is present at the center node, and it consists of 6 electrons in its outermost shell, as you could see over here. It is 6 electrons in its outermost shell, and that's the reason I am representing it with the dot over here. I'm talking about the fluorine. Fluorine consists of 7 electrons in its outermost shell, and I am representing it with the cross. So here we have I am representing the electrons of the fluorine by the cross, so as to differentiate between these two, and that is how we could see that at every sulfur, basically 6 fluorine would be attached, and that is the reason that I am representing it in this way. I'm not representing the overall that is valence electrons of the fluorine, but just to understand that basically to understand the valence electrons of its outermost shell of the sulfur. That is the main thing, because fluorine is the one that will follow, that is or that will obey the octet rule by forming 8 electrons in its outermost shell. So that is fine. But talking about the sulfur, so sulfur is the one that will acquire basically 10 electron, basically more than 8 electrons, and now here it is basically 12 electrons. How we could say that is 6 electrons were in the outermost shell of the sulfur when it was in atomic state, but when it is forming a molecule, we could see that there are in a total of 12 electrons, that is 6 electrons of the sulfur, while 6 electrons of the fluorine. They share with each other, and that is the reason that the bond are being formed, and that's the reason that we could see a bond is being formed, that is 6 bonds are being formed, and that is how the fluorine is forming a bond with sulfur. But talking about the sulfur has more electrons, more than 8 electrons in its outermost shell when it forms a bond with the fluorine, making it of 12 electrons, and which is very much higher than the octet rule that we have did in our previous lecture. So this is how this is known as the expanded octet, and that was not been it was a limitation of the octet rule, but still the compound is more stable. And so these were the two reasons of that is limitation of the octet rule. But talking about the next one that I am going to talk about, that is odd electron. So there are also certain molecules that are basically following the which are not following octet rule, but still they are basically stable in nature. So suppose we are talking about odd electron. So let me give an example in this case, that is the structure that is NO. The molecule NO, so we could say that the bond can be, or the representation of this can be shown in this way, where the nitrogen, which has basically one lone pair of electrons that is been placed over here, while the rest of the 3 electrons that are being placed over here, and it has been combined with that of the oxygen. And oxygen is the one which has basically 6 electrons in its outer motion, and out of which the 2 are the responsible for formation of the bond. So these are the 2 lone pair of electrons, while these are the 2 electrons that are responsible for the bond. So now here we could see that the bond has been formed between the nitrogen and oxygen. But talking about this electron which is now left out, we are not counting this lone pair of electron, but we are counting this one. So this electron has been left out, and still it has not been forming a bond with any kind of other molecule, so making this to be still stable. And therefore there are certain molecules that have odd electron, but still they are more stable, and that is how the octet rule has failed, or there is a limitation of the octet rule. So that is it, friend. That is what I wanted to explain to you. So thank you, friends, for watching this video. I hope you have understood this video very clearly, and will share this video with your friends. And don't forget to subscribe to Ekeeda channel. Thank you so much.